Okay, error in measurement comes about because when we measure something, we don't measure it exactly. So say we measure something and it's 80 centimetres, and I've gone to the nearest centimetre. It could be 80, or it could be 80.1, 80.2, 80.3, all the way up to 80.4. 80.5, I would have said 81. So it's got to do with rounding. And I could go to 79.9 and all the way down to 79.5 would give me that 80. So we've done error before, and we know that the absolute error is half the unit. So in this one, the absolute error is 0.5 of a centimetre. The percentage error is the percentage of the measurement that we got wrong. I'll have a look at an example on that, and then I'll go on to the new bit. So this is from the preliminary course. Hilary has her height at 164. The measurement is given to the nearest centimetre. Between what two values can her height be? She could be 164.4.5, but not, so we don't put equals. And here, she could be 163.5. and anything between those, like I explained over here. What is her percentage error? Well, the percentage error is the absolute error, which is half of a centimetre, over 164 times 100. Let's get out my calculator. Very excited, it's finally on the computer. 0.5 on 164 times 100. So it's 0.3% error, so it's not very big error. Okay, the mass of a trailer is, soil is 260 kilograms. The mass is given to the nearest 10 kilograms. So that means that the absolute error is 5 kilograms because it's half of that. Between what two masses could it lie? It could be 265, but if it was equal to 265, we would round up, so we don't put the equals there. We put the equals down here because it could be 255, and we would round up. And the percentage error is the absolute error, which is 5 on the original value times 100. Okay, and that error is 1.96%. And obviously, if I'm rounding to the nearest 10 of a kilo rather than the nearest kilo, the percentage error is going to be higher than up here where I rounded more accurately. I need to look at area, and I need to look at absolute error with area. So if I look at, say, a square, let's make it a rectangle, and I've got 6 centimetres by 2 centimetres, and I've measured to the nearest centimetre. Okay, this 2 could be 2.5 or 1.5, and this 6 could be 6.5 or 5.5. Now if I wanted to find the area, I would times the 2. So if the question says what is the range of the errors with the area, 12 would be the answer I gave because I've rounded. But what's the biggest possible area? It's 2.5 times 6.5, because it could be up to 2.5 and 6.5. So it could be as big as 16.25. But it also could be as small, and I don't know why that's not working. It could be as small as 1.5 times 5.5. Sorry, I know that makes for a boring video. 8.25. So when we're looking at errors in area and volume, we have to consider the error in both sides. So say, let's do a volume one. Let's say this was of depth. Well, let's say it's a cube and it's 5. Let's go with a cube that's 5. The original area would be 5 cubed, or between 5.5 cubed or 4.5 cubed. Why cubed? Because it's a cube, length, breadth, height. So that would give me my upper and lower boundaries for the volume.